All right, guys, this is the 8.6 lesson where we named the states, and we're going to go through the check for understanding. If you haven't read it yet, I'll give you a minute or two, and then just resume the video, okay? I'm going to model it with state plan do conclude. What are we trying to do? We are trying to create a 90% CI, that's confidence interval, for mu. And what is mu? It is the mean tension of all screens produced in a day. Produced on this day. So that is my parameter, mu. I am learning as I read this. I didn't know about this tension of video terminal screens. The plan will be to do a one sample T interval for mu, because this data is coming from one sample. It's a T because we're going to use the standard deviation rather than sigma, rather than the population standard deviation. We should, in part of our plan, we should always check conditions. Is it random? It said, did it say random up there in there? I'm sure it did. Here it is, yep. Random sample. So I would say stated in the problem. It was a random sample. After random, you check, is it normal? Question mark. So is the sample large enough? Is 20, so n is 20, but 20 is not big enough, folks. 20 is less than 30. Uh-oh, frowny face. So what am I going to do? Well, when this happens, what you're going to do is you could take this data, you could put it in your calculator, you would go to stat, edit, and you would start entering all the data in the calculator. Like the first one is 269.5, then 297.0, and so on and so forth, right? It'll take a little time, but you could do it. Then you're going to create a histogram, or well, you guys can't make dot plots on your TI-84, but make a diagram, a bar graph, a histogram of some kind, so you can look at it and try to determine the shape. Remember, just a quick little aside, to make that show up, you have to go to stat plot, which is second y equals. I know my menu looks different than yours, but on the stat plot menu, you can turn on a plot, and you can change it to be a line graph, a histogram, a box plot, whatever you need, okay? So you may need to take time to do that when n is less than 30. So I'm looking at this when it's less than 30, and the sample size is small, but the dot plot does not show any skewness. Is that a word? Skewness or outliers. So we will proceed with caution. Okay. We will proceed with caution. In other words, we're going to move forward. Okay. And we're going to do our analysis anyway, but we're going to kind of realize it might not be perfectly applicable. So random, normal, and then independent. What was our sample size? It was 20. So is 10 times 20. 10 times 20 is 200. is that less than the population of all screens made in a day? And I guess here we'd have to make a little bit of assumption. I'm going to put a check mark, be like, yep. You could also maybe claim that the tension of one TV screen is independent of another's. Okay, but comment on it. Then we're going to do it. Let's list what we know. We know, let's change up the color here. We know X bar. It said, wait. We don't know X bar. Oh, shaboodoo. So how are we going to get it? Well, you're going to have to take time right now on your calculator to put all of this into list 1, like I was talking about. And then once you have it in list 1, you're going to go stat calculate. You're going to do number 1 right there, good old 1var stats. And I have to type in list 1, and boom. That's how you're going to get the data we need. Now, those numbers you're looking at right there are not correct because I did not enter all of the data. Okay, so you need to take time right now and do that. And when you're ready, hit resume, and you can see what the answers should be. Turns out X bar is 306.32, and SX is 36.21. Okay, those are, well, and I guess N is 20, but you probably already knew that. Those are the 3 numbers you need to pull out of it, okay? Also, we need to know our degrees of freedom. DF is 20 minus 1, so it's 19. Okay. I'm going to use that to get my T star. I need to look at my packet. So in my packet, remember, I'm going to look up 90% and 19 and see where they intersect. Here's my formula sheets. Let me clean this up a little bit. I'm going to look up 90% and 19. So here's 19, this row. Degrees of freedom, right? Degrees of freedom, 19. And then 90% is this one. So they give me this, 1.729. That is my T star, my critical value for this. All right. Then my formula is X bar plus or minus T star times SX over the square root of N. But I've got all of my ingredients now, so let's just put it together. 306.32 plus or minus 1.729 square root, or parenthesis, 36.21 divided by the square root of 20. If I take that a little bit further, 306 is my point estimate. That's the middle. Plus or minus, what is this? Type it in your calculator slowly, see what you get, but you will end up with 14. Comes out to be pretty much 14 spot on. Now remember, what is this? This pink is the margin of error. Okay, MOE. So go ahead then on the calculator and get the final answer. 306.32 plus 14. Oh, why do I always start with the plus? I should do minus first. Maybe that is makes more sense. So with interval notation, my interval would be 292.32 up to what? Just do it again by adding 320.32. So that's my interval. Okay. Conclude, we can interpret it. So we are 90% confident, and I mixed it up here a bit. I moved the blanks around. I'm doing this just so you can be flexible. because it might be worded differently from one test to the next. So the interval from 292.32 to 320.32 captures what? What are we measuring? Well, I'm just going to kind of take this from up here. Maybe you can't see that I'm copying, whoops. I'm trying to copy the parameter from up top. And I'm going to just paste it down here. Oh, it grabbed the whole graph. Whoops. Let's see if I can do that better. Probably, maybe not. I am struggling. Hop on the struggle bus. Hey, there. The mean tension of all screens produced. Okay, there you go. Then follow up. Let's use our interval to answer question 2. The manufacturer's goal is to make screens that have an average tension of 300. Based on our interval, right here, is there convincing evidence that the screens produced this day do not meet the goal? Explain your reasoning. Is there evidence that they're not meeting the goal? The answer is no. It's the opposite. The evidence actually shows that their goal could be met or is likely being met. Because 300 millivolts MV is contained in the interval, another way you could say that is because 300 millivolts is a plausible value, there is not convincing evidence that the screens produced don't meet the manufacturer's goal. Because again, 300 was well within this range.